Guys, today we are going to take a look at this problem. Is education of Codeforces round 29, problem D. Alright, so we are going to have an array and we can have two kinds of operation on the array, right? So the first kind of operation is to sh shift the array to the right, right? So it has a left point and a right point. So we need to shift this segment to the right. And the second kind of operation also indicates a segment. It has a left point and a right point, right? And it will reverse the segment, right? We will explain it later. We can just look at the example here, right? So what do we do to the array here? So before we explain the operations, we take a look at the first number. The first number means the length of the array, right? So we have 6 numbers in the array. And the second number here means the number of operations we are going to have on this array, right? So we are going to have 3 operations, 1, 2, 3, right? So both of those operations has a left point and a right point, right? And finally, we are going to have 5 important indexes in the last array. We will going to explain it later. So here is our initial array, right? Same as this one. And after the first operation, right, we're going to have this array. So the first operation is the second kind of operation, and it starts from left, this index, to right, this index, right? So this part, this segment, is going to be reversed to like this, 1, 2, 3, transform into 3, 2, 1, right? And same as the second operation, right? For the second operation, it starts from the third index, right, to the last index, 3 to 6, right? And we are going to reverse it to here, right? 1, 4, 5, 6 transform into 6, 5, 4, 1, right? So this is our result array. And we are going to do the third operation. The third operation is the first kind of operation, right? So we are going to rotate it to the right. So for this segment from the first to last, right? For this whole array, we're going to shift it to the right, right? 2, 6, 5, 4. And the last number will become the first, right? So this is our final array. So what are we going to do with the final array? So we have an array of important indexes. So we are going to output these indexes, right? So what's index 2 here is 3, right? So we output the 3. What's index 2 here is 3, so we output the 3. What's index 1 here is 1, so we output 1. What's index 5 here is 5, so we output 5, right? What's index 2 here is 3. Oh, sorry. What's index 3 here is 2, right? So we output 2. Cool. So that's how we do the operations on the array and how we get the output here, right? So how do we solve this problem? The naive solution is that we create an array and iterate all these operations and apply these operations on this array. But the difficult part is that the number of numbers, which is n, and the number of operations, which is q, is quite large, right? So we cannot solve it using the naive solution. But as we noticed, the number of important indexes, which in the last array is relatively small, right? It's just 100 numbers in the last array. So we can make use of that. So how to make use of that? So we know what's the important index in the last array. These important indexes are those we really care about. If it is not in this, if it is not important, we don't really care about it, right? So we can work this from bottom to top, right? We know 100 important index here, and we can move it from bottom to top. So we can know where the important indexes are in the initial array in this way, right? So what do I mean? So let's take an example here. So we look at the index 2 here. So uh, in the end, the index 2 is at the second position, right? So where is it in the second last array? Is here, right? Sorry, it's here. Because in the last operation, we shift all the numbers to its right. So if we reverse it, we shift the numbers to its left, we can get the uh, get this index position in the second last array, which is here, right? And we move it up once again. We can know that before the second operation, this number is here, right? Because the second operation apply on the segment from index 3 to index 6, so it doesn't affect the index 1, right? So index 1 stay in the same place. So then we can move it up again, right? So the first operation reverse from index 1 to index 3. So the way we reverse this operation is to reverse from index 1 to index 3, right? So we reverse these guys. So we got this array, and we find out this index eventually get to here. And what's the number at this position? It's 3, right? So we output 3, right? So let's take another example. All right, let's take 3, index 3 here, right? So in the last array, the index 3 is at the third position, right? And let's reverse the last operation. So we move every number to its left. So we can know that this index become at position 2 here, right? And after we reverse the second operation, this index become at the same place because the second operation applies 3 to 6, so it doesn't affect this one. So for the first operation, we reverse from index 1 to index 3. So um, the second position doesn't change, right? So it still remains the second. So what do we got from the second position? We got 2. So we output 2, right? So work from bottom to top is our way to solve this problem. So let's look at the code, right? So for this part is read the 3 numbers, and for this part is to read the initial array. For this part is to read all those operations, and we uh, iterate each of the important indexes, right? So for each indexes, we output a result, right? And the way to find the result is to operate those operations from bottom to top, right? From Q to 1, right? And for each operation, we check if the current index is inside the current operation, right? So J is the current index of the operation, and Lj is the left point of this operation. Rj is the right point of this operation, and if current position is included in this segment, we are going to reverse this operation, right? So if it is the first kind of operation, the way we reverse it is is to shift it to the left, right? And if it is the second kind of operation, the way we reverse it is to reverse it from left point to the right point, right? After we reverse all of those operations from the last one to the first one, we can get the uh, final result, right? We are going to output it, right? So I guess that's it. Thank you for watching. Bye bye.